This is practice test number 5, and we're working on problem 9. And the problem states that the mean life of a light bulb is normally 7,500 hours. The population standard deviation is 1,000 hours. And a random sample of 64 bulbs indicates a sample mean of 7,350 hours. And I've made notes here of what each of these numbers represents. The 7,500 hours is the mu, or the population mean, of the light bulbs. The 1,000 hours is the standard deviation for the population. And out of that population, we took a sample of 64 bulbs, which is our sample size n, and we had a sample mean x bar of 7,350 hours. So what we want to determine is, does this sample mean of 7,350 hours, does it indicate that the mean life of the bulb is no longer 7,500 hours for the entire population? Has it changed? And so the question is, at the 0.05 level of significance, is there sufficient evidence that the life of the light bulbs is different than 7,500 hours? The first thing we want to do is to construct a null and research hypothesis. And the null hypothesis always states that there is no difference, meaning in this case that the sample mean, the x bar, is part of the population of the 7,500 hours. The alternative hypothesis states that there is a difference, that this sample mean indicates that the life of the bulbs is no longer 7,500 hours. On letter B, you're asked to draw a normal distribution curve with rejection and non-rejection regions based on a 0.05 level of significance. And so what I would want you to do is to draw this normal curve. And then, based on the level of significance, 0.05, the z is going to be equal to 1.96. We've seen that number quite a few times before on the positive side, and then the z is going to be equal to minus 1.96 on the negative side. The population mean of 7,500 is in the middle of the curve. Now we're going to calculate our z-stat in a moment, and if that z-stat falls anywhere between these two z-scores in this region of the curve, this is called the non-rejection region, and if our z-stat falls in this region, we would not reject the null hypothesis. But if the z-stat falls anywhere less than minus 1.96 in this region, or if it is greater than 1.96 in this region, then we would reject the null hypothesis. So these two regions are labeled as rejection regions. And then we want to, on letter C, state our decision rule. And our decision rule is going to be that we would reject the null hypothesis if the z-stat is less than minus 1.96, that is, it falls in this region, or if the z-stat is greater than 1.96, it falls in this region here. Otherwise, we fail to reject the null hypothesis. So on letter D, now we're going to calculate the z-stat, and you have the formula here for the z-stat. It is the x bar, the sample mean of 7,350, minus the population mean, the mu of 7,500. And on the bottom, we have the standard deviation for the population of 1,000 over the square root of 64, the sample size. And then on top, we're going to have minus 150 On the bottom, we have 1,000 divided by the square root of 64, which is 8, and that's going to be 125. When we do this calculation here, we're going to have a z-stat of minus 1.2. So if we look up here and find out what region that falls into, we find that it's somewhere in this area here. It's to the right of the minus 1.96, and so it falls into this non-rejection region, which means that we are not going to reject the null hypothesis that the life of the light bulb is still 7,500 hours for the population mean. And so down here we're going to state our decision and why with our conclusion. The decision is that we fail to reject the null hypothesis since the z-stat is equal to minus 1.2. There is insufficient evidence to conclude that the mean life of the light bulbs has changed from 7,500 hours.